Good morning, everybody. Welcome to week 2 of distance learning. We're almost to spring break, but I wanted to do a quick lecture about solving basic trig equations before we go. So I put our good old friend, the unit circle, right here. On your handout, it is not filled out because I wanted you to practice filling it out, but on mine it is for the sake of time. So just a quick review of the circle. You'll probably remember that every coordinate is special in that it has a connection to the sine and the cosine. So any coordinate on here, remember that in first position is cosine, second position is sine, right? And so in a lot of these equations, I'm going to be asking you, what is the cosine of this? What is the sine of that? And so it's going to be really useful to note that where the sine and the cosine are. So let's go ahead and start with the first one. So let's say I asked you, what is cosine of x equals -1. So notice that before this, you would tell me this value on the right-hand side, but now I'm asking you to tell me this value after the sine or cosine, right? So remember that after sine or cosine, we always have, so this would be cosine of something equals -1. And remember that this must be theta, aka some angle, right? So you're not putting these numbers anymore. So these ones with you used to give me these in a previous quiz that we did, the coordinate, either the sine or the cosine. But now you're giving me the angle. So you're going to be telling me this, anything in here, as your answer. Okay, so now we moved inside of the circle. So let's go ahead and look at the circle for a second. Let me get rid of all these yellow marks. Okay, so we're looking for a cosine that is -1. So let me go ahead and highlight some of the cosines for you. So cosine, 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 cosine. Okay, and what we're looking for is which one of these has a cosine that is -1. So let's go one by one. Nope, that one's 1. Nope, 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 nope. There we go, right? So see how here the cosine of whatever angle is equal to -1. So the question is, what angle is that happening at? And if you look at the circle, you will see that that is happening at pi. So the answer to this question would be x equals pi, which is exactly what would happen. You might remember you might remember that we used to do this with the calculator. So if you did this cosine inverse, you would end up with pi as your answer. Okay, so that would be the answer to the first one. Okay, let's look at the second one. So here it's saying sine of x equals radical 3/2. So pretty much this is asking where, that's not where is sine equal to, equal to radical 3/2. And here's the interesting thing. You'll notice that there are not just, let me get rid of all the, so these were all the cosines, right? Now let me highlight all the sines. Okay, so now we're focusing on sine. So sine is going to be second position. So there's sine, and we're looking for where is sine radical 3/2. And so the interesting thing you'll notice is I see 2. There's one here, and there's also one here. Okay, so this is option 1, and here's option 2. So we have to list both when we are stating the answers. So x can be either, let's see, this one is at pi over 3, or what's this one? 2 pi over 3. Okay, so notice with this one there are two answers. Okay, so I'm kind of turning you into little mini calculators here. So remember, we used to do this sine inverse, cosine inverse, or tangent inverse on the calculator. So really, I'm getting you to see that what the calculator is doing is it's asking at what angle is this fraction happening at, right? So again, your answers come from inside of the circle. No longer are they coming from outside. So your answers are in here somewhere. And usually, I'm not saying always, but usually we stick to the radians. That's a little more common, but you'll see. Sometimes it'll ask for degrees, sometimes it'll ask for radian. Okay, so let's come down here. So now it's asking for where is cosine 1/2. So again, let me get rid of all this junk on my circle. Junk. Okay, so where's the cosine -1/2? So I'm not going to highlight everything anymore. I'm just going to focus on cosine. So cosine is first position, so I see a -1/2 here. And I also see a -1/2 here. So that would mean this is one of the special angles, and this is one of the special angles. So my answer would be theta can be 2 pi over 3 or 4 pi over 3. Okay, so these become really quick if you can look at the circle really quick and figure out the answer. Okay, next one. So now I want tangent. So here's the thing with tangent. For tangent, remember that we didn't have it specifically on the circle. So you could go around and fill it all out. Or you could just remember that tangent, you might remember that meme that we talked about. So you might remember that tangent is the same as sine over cosine, right? So we're pretty much looking for where in the circle is the sine number the same as the cosine number. So that would happen here, right? And that would happen here. So if we think about here, this tangent would be radical 2 over radical 2, which would give you 1. That's what you want. This one would be negative radical 2 over negative radical 2, which would also give you 1, which is what you want. So these are our two answers. And you might be wondering, how come these ones don't work? What about this one, right? These two are the same as well. Well, they're almost, except for a sign a sign difference. So this one is radical 2 over negative radical 2, so that's actually going to give you -1. Same thing here. This is going to give you -1, and we want +1, so those won't work. Sorry. So your two answers are theta can be pi over 4, or theta can be 5 pi over 4. Okay. All right, now we get to this one, and you're like, oh man, that one looks super complicated. Well, kind of. So we know that our goal is to see if we can figure out what sine is, because once we figure out sine, we can see what fraction we need from the circle. So I need to get rid of this radical 3, and I notice that it's plus radical 3. So the inverse of doing plus radical 3 would be minus radical 3. That goes away. So this is 2 sine x equals negative radical 3. Now we got to get rid of this 2, right? So how do we get rid of multiplying by 2? Divide by 2. And so now we're looking at, oops, let me see if I can lift this up. Now we're looking, where is sine x equal to negative radical 3 over 2? And again, if I go over here to the circle, I can see, sorry, I gotta get rid of this stuff. Okay, so if I want sine, remember sine is second position, so negative radical 3 over 2. So I see 1 here and 1 here. So that would make one of the answers 5 pi over 3, the other answer 4 pi over 3. So x can be 4 pi over 3 or 5 pi over 3. Okay, almost done. So now we have a little bit of a push. So now we have cosecant theta. And you're like, oh man, cosecant isn't on the circle. But hopefully you remember which trig functions are related to which other ones. So let me remind you really quick in case you forgot. So I'll do it over here on the side. So we know the main ones are sine, cosine, and tangent, right? So just think for a sec while I'm writing this out. So sine's buddy we call cosecant. Cosine's buddy we call secant. And tangent's buddy we call cotangent. So I'm seeing secant right now. So that's this one. I mean cosecant right now, which means I'd like to turn that into a sine if possible. So how would I do that? Well, I would go right here. And remember we talked about the reciprocal. So I can turn cosecant into sine as long as I flip the fraction. So I'm really asking where is sine equal to -1? And that's pretty easy. If I go around the circle, I see the only spot is right there. So for this one, theta would be 3 pi over 2. Okay. And then for this last one, kind of same idea. I want to find secant, but secant isn't on the circle, right? There's secant. But I know that I can turn that into cosine. So again, I just have to use that same idea. So I can turn secant into cosine theta as long as right now this is 2 over 1. So I'm going to flip it to 1 over 2. And so I'm looking on the circle. Let me bring this back up real quick. So I'm looking on the circle for where is cosine, or where is the x value 1/2. So I see it here and I see it here. So that would be pi over 3, 5 pi over 3. So theta can be pi over 3 or 5 pi over 3. Okay, so I'm hoping that's not too difficult. We're going to spend the rest of this week practicing this and doing different equation styles like this. I'm not going to include these ones on the back in the video, mainly because they're just time consuming, but I would like you to practice them. I know these ones with the squares might be a little bit of a stretch, but feel free to come to office hours as needed. All right, have a good week. Almost spring break.